Good day, everybody, and once again we're back together. All right, so we are looking at question 10 from our technical maths paper 2 exam. So please, if you haven't subscribed, just make sure you're part of this family. All right, let's get into the question. So, in the question, they say the picture and diagram below show the wheel, the rear wheel of a training bicycle. The rim has a radius of 26 inches and the thickness of the tire is 24 millimeters. Right, I think the first thing that I notice is that we've got two separate dimensions that we're using, millimeters for one and inches on the other. All right, so they say to us, convert 26 inches to meters if 1 inch is equal to 0.054 meters. Right, so that's quite straightforward. So if we wanted to find out what is 26 inches, we'll take 26 multiplied by, remember that 1 inch is 0.00, it's 0.02. Okay, let's erase that. So that's 0.0254. Okay, and let's use our calculator for that. Okay, that's going to give us 26 multiplied by 0.0254, and we get 0.66. Okay, we can approximate that to 0.66 in two decimal places. Okay, 0.6604, that's in meters. Okay, right, so that's how we answer the first question. Now they say to us, calculate in meters the diameter of the wheel, which includes the tire. All right, now let's quickly have a look at it. So if we were to look at the wheel, firstly, we've got the diameter of the rim plus, in this case, we need to add the thickness of the tire. Okay, so that we get to the circumference of the tire, right? But of course, I mean, when we talk about diameter, it means that we need to take twice that, okay? So firstly, let's calculate the radius of the entire wheel, and then we can multiply that by 2. So I'm going to say, right, the radius, okay, so this is 10.1.2. Okay, 10.1.1. So the radius of the wheel would be equal to, I'm just using a different iPad today, so I'm not able to write as nicely as I usually am able to. So radius is equal to, so we said 26 inches, but we know that's going to be 0.6604 plus, in this case, we said the tire is 24 millimeters. Now remember, because I already have the radius of the rim, right, in meters, I need to convert the tire to meters. So remember, milli, we divide that by 1,000. So I would divide that by 1,000, which would give me 0.0, okay, 24. Okay, right, so that would be plus 0.024. And what does that give us? So taking our calculator, I'm adding there 0.024. Okay, and we get 0.6844. So 0.6844, that's in meters. But remember, that's only the radius. So we need to still multiply that by 2 to get the diameter. So multiply that answer by 2. Okay, and I get 1.3688. Okay, you can say 1.37 if you want to. So that's 1.3688 meters. Okay, right. So that is the dimension of our, the diameter rather of our wheel. Okay, and that is inclusive of the tire. Right, and the final question on this section here, they say, if the circumferential velocity of the of a particle rather on the outer edge of the wheel is 60 kilometers per hour. They say determine the rotational frequency of the wheel in revolutions per second. Right, now essentially they're simply saying to us, if we were to place a particle, let's say somewhere there, right, it does have a circumferential velocity, and remember that circumferential velocity would be given to us in revolutions per second. Okay, so what are we looking at? We're looking at saying, well, in this case, there's an equation as a formula that we're given. Okay, and I'm going to take you to your formula sheet there. Okay, so that you can see it. Yeah, where is that? Yeah, there. Circumferential velocity, V is equals to pi d, right, multiplied by n, right? And what is n? That's rotational frequency, okay? But we are now looking at finding the circumferential velocity for this tire. And I need you guys to be aware of this, right? That once we have been able to do that, okay, we'll come back to that in just a bit. So let's do that. Okay, where's our question? There it is. Right, so they say to us, okay, they said the circumferential velocity is 60 kilometers per hour. So V is equal to pi multiplied by d multiplied by n. But I want you to note in this case, we need to convert this to kilometers, to meters per second, right? Our radius is in meters, so we need to convert that entire thing to meters per second. And so how do we do that? Right, so our velocity is 60 kilometers per second. Right, so that's 60 kilometers per second. And now remember, in 1 kilometer, there is 1,000 meters. So you multiply by 1,000. And then for the hours, kilometers per hour, if you convert hours to seconds, that would be 3,600. That's 60 times 60. Okay, so I always say you just divide by 3.6. Okay, that's the easiest way to convert from kilometers per second per hour to meters per second. So what do we get there? Right, so that's 1,000 into itself once, into 3.6 into 3,600. That's 3.6 times. So that's 60 divided by 3.6. Okay, let's take that. 60 divided by 3.6, and we get 16.67. Right, so that's the circumferential velocity, 16.67. Right, that's equal to pi, but we have already calculated our diameter. That's 1.3688. Nothing wrong if you decided to leave that as 1.37. Okay, and finally, I'm just going to divide both sides by pi multiplied by 1.366. Okay, there we go. That's 1.3688. But remember, what I do on the left, I do on the right. Okay, that cancels out with that. And so, what is our final answer? So I'm going to say 6.67. Right, I'm going to divide that by, let's put that in brackets. That's pi multiplied by 1.3688. And I close those brackets. I get the number of revolutions per second. That's 3.8, let's say 3.88 revolutions per second. And by the way, it is very important to note in this case that that's what we're looking for, the rotational frequency in revolutions per second. All right. So, ladies and gents, that is how the cookie crumbles. We're going to leave it at that for this question. Right, catch us again when we look at the next question. I'll see you guys again next time. Sharp, sharp.